Okay, so let's go ahead and complete the rest. So we did the arc sine, we did the arc tangent. So let's go ahead and do the arc secant here. So the arc secant is, again, y is equal to the arc secant x, which means that, again, the secant of y is going to be equal to x, right? So if you go ahead and take the derivative here, I'm going to get 1 is equal to secant y tangent y, right? Because the derivative of secant is a secant tangent, and I have to do the derivative, and I have to do the chain rule, and that's where I get the y prime from. So y prime is going to be equal to 1 over secant y tangent y, okay? Where I know that secant y is x, so I can make the substitution here as this being x, okay? The question is what I'm going to do with the tangent y, right? So again, as we had before, I had tangent squared y plus 1 is equal to secant squared y, right? And we're trying to find out what tangent y is. So tangent y is going to go, if I move the 1 over here, it's going to look like this, and I'll take the square root. I'm going to get basically 1 plus or minus x squared minus 1, right? Because this is going to be x, so it's going to be x squared minus 1. So I'm going to take the square root of that. So that's why I get the plus or minus, and put the plus minus up on the top, and I get this guy. Okay, so this is kind of good or not good. Okay, so we're saying that what? This can't be 0 or this can't be 0, right? Or actually this has to be what? Greater than 0. The inside has to be greater than 0, right? So x squared minus 1 has to be greater than, or actually greater than 0. Greater than 0, right? So that's a 0. I'm going to read that. It's a 0. So x squared has to be greater than 1. In other words, that has to be greater than 1. Okay, because if I do this, this automatically gets rid of this guy. This guy's never going to be 0, right? Because if this is 0, not only is this 0, this is actually negative 1. So it doesn't work anyway, okay? So I don't have to worry about this being 0. Okay? But I do still have the plus or minus thing here, right? Which is kind of cumbersome, okay? All right. But we don't have the luxury of cosine y being greater than 0 all the time like we did when we had arc sine. So the way we get rid of this is we're going to go ahead and just say, I'm going to go ahead and call this, get rid of the plus or minus, and I'm going to go ahead and meld that plus or minus into an expression like this. Okay? So in other words, it's still going to be, this is always going to be positive, right? So when I have this, okay, and I'm going to say that since I know this, okay? And so this is actually our expression. This is the final answer. Okay, so if we go ahead and put this in U's like I did before on the other ones, my equation is going to look like this. dx secant u is going to be equal to 1 over u squared minus 1, and u has to be greater than 0. Actually, there's a du dx. This is the chain rule, right? So this is what it's going to look like. Okay, so this is your third one. This is the third and last one. So we had the arc sine, the arc tangent. This is the arc secant. Okay, so that's our final answer. So if we can go ahead and see if we can use this. Where are we at? We are arc secant. So that would be example number 3 on page 176. On page 176, example number 3, using the formula, see if we can do d dx arc secant of 5x to the 4th. So I'm going to go ahead and take this and put that in there. So I'm going to get 1 25x to the 8th minus 1. And then you have to take the derivative of this guy, which is 20x to the 3rd. Okay. However, if you look at this, this is always going to be greater than 0, right? 5x to the 4th. There's no way this is negative, so I can actually get rid of the absolute value bars there. I can get rid of that. Okay. And I can go ahead and now say x to the 3rd. That gets rid of that. This becomes 4 over 25x to the 8th minus 1. Okay. And where am I at? So that's that. That's the answer right there. Am I missing an x? Oh, there's an x. Or there's an x left over here. Okay. X. Like that. Okay. So that's what it looks like. Okay. So the rest of the stuff, what about the rest of it? So what about arc cosine? What about, arc cotangent? What about arc cosecant? And if you look on the bottom of page 176, it gives you the relationships that you can use to find the other ones. So in other words, if you were asked to find the derivative of arc cosine, okay, you would bring out that relationship, and you would say, well, since I know that the arc cosine, right, arc cosine of x is equal to pi over 2 minus arc sine of x. If I want to know the derivative of this is basically the derivative of this, which is what? Basically the negative, so this guy goes away, the negative sine negative x, the derivative of that guy, right? And we already know how to do the derivative of the arc sine, so this is how you would solve that. Okay, and the same thing goes for all the other ones. Okay, so let's see if we can do example number 4 and utilizing one of these relationships to find another one. So let's go to example number 4. Find an equation for the tangent line of the graph. Y is equal to arc cotangent x. So y is equal to arc cotangent of x, right? At x is equal to -1, okay? Well, when x is equal to -1, what do I get? What is y here? So I'm gonna get, so what do I get? I'm gonna go ahead and, let's go ahead and cotangent, what is the relationship we're using? Cotangent, arc cotangent, x is equal to 1/2 minus x, right? This is what we're using here. So first of all, I need to find what the y value is here, right? So arc cotangent of -1 is equal to pi over 2 minus arc tangent of -1. So what is the angle that gives me tangent -1? That would be negative pi over 4, right? Minus pi over 4. So this guy goes like that. I get 3 pi over 4. So the point is -1, 3 pi over 4, right? Since I need the point, right? Not only do I need the slope, I need the point also. So I found the point. Okay, this is what I did here. Okay. Now that I've done that, now let's see if I can go ahead and see what happens when I take the derivative here. So if I find the derivative, so this is going to be the same as negative the derivative of this guy, which was what? This was 1 plus x squared, right? So there's a negative here, and I have that. So if I evaluate this when x equal to -1, I get -1 plus 1, -1/2. So this is my slope. This is my point. So I get y minus 3 pi over 4 is equal to -1/2 x minus 1, so it's plus 1. would be your answer. Yep, that's it. Okay, so if you're worried about the tests and all and stuff like that, okay, the answer is really no. I am not going to ask you, I'm not going to ask you something that's really elaborate here. At most, I would give you like arcsine or maybe arc tangent or one of those two, okay? The other ones you don't really, I mean, I would expect if you ever had to get that when you're in your future math career, you would look it up in the book, okay? But, as a minimum, I would probably ask you to be able to whip out arcsine and arctangent. Probably those are the two that I probably would do. Okay, does that make sense? All right, I hope that makes sense. Okay, so